everyone, we are
Moses.
Lydia. Today we will be presenting chapter 6 titled Dynamics. This chapter explores an essential concept related to the motion of objects.
Let's begin with early Greek theories. Aristotle and his followers believed that objects could have two types of motions, natural and unnatural. Natural motion was thought to be caused by an object's internal qualities, while unnatural motions require an applied force to sustain it.
Then came Galileo, who challenges Aristotle's ideas. He proved that heavier objects don't fall faster than lighter ones, and air-resistant falling objects with lighter ones being more affected. Galileo also demonstrates that motion does need continuous force, like an arrow continuing in a vacuum. This led to Galileo's principle of inertia. An object in motion will continue at constant velocity unless acted upon by external force.
Building on Galileo's work, Isaac Newton formulated his three laws of motions and the theories of gravity, which laid the foundation for classical mechanics. His laws provide a comprehensive framework to explain the motions of objects, and while they apply to everyday situations, they don't account for subatomic particles or objects moving at speeds close to the speed of light.
Now let's dive into forces. A force is a push or pull that can change an object's state of motion. Forces have both magnitude and direction. Understanding them is the key to studying dynamics.
First, let's talk about balance force and unbalanced force. Balance force occurs when the sum of all forces acting on an object is zero, meaning there is no changes in motions. Unbalanced force, on the other hand, causes a change in the object's state of motions. Equivalence force is a force that balances out other forces, making the total force acting on the object zero, just like in the cases of balanced force. It has the same magnitude as a combined force but acts in the opposite directions, ensuring equilibrium.
Forces can be classified as either fundamental or mechanical. Let's take a look at the fundamental forces. The first is gravitational force, a long-range force proportional to the masses of interacting objects. It governs the motion of planets, the structure of galaxies, and other large-scale phenomena. The second is the electromagnetic force, discovered by James Clerk Maxwell, which governs interactions between charged particles. The third one, strong nuclear force, binds protons and neutrons in the nucleus. The weak nuclear force is evolved in nuclear decay process and essential for nuclear reactions.
Finally, force can be divided into non-connect and connect force. Non-connect force, like gravitational and electromagnetic force, acts over a distance without physical contact between objects. Contact force such as tensions, compressions, frictions, and shears requires physical interaction between objects.
Now let's look into Newton's law of motion. Newton's law of motion is divided into three parts. The first law, also known as the law of inertia, states that if all forces are balanced, the system acceleration will be zero. This means that an object at rest will stay at rest, and an object in motion will continue moving at constant velocity.
The second law, known as the law of accelerations, explains that the accelerations of a system is proportional to the net force applied and inversely proportional to its mass. The formula is F equals ma, where force equals mass times accelerations. The third law, the law of actions and reactions, states that for every action force, there is an equal and opposite reaction force. This is illustrated by the examples of a rocket, where the force exerted by the engine gases causes the rocket to move upwards.
This is the end of our presentation. Thank you for your attention.